Virtualization Product Management, and I'll be joined by my colleague Brad Lackey, who's a manager of Oracle Desktop Virtualization Sales Consulting. Today we're talking about Secure Global Desktop, and for our agenda we'll be talking about Oracle Desktop Virtualization and access and what's happening generally in that space with Oracle. But also then we'll get into the product and talk about the challenges facing administrators and users in accessing their information in a dynamic world. Go through the product and features and architecture and how it works, how Secure Global Desktop is an important part of any efficient virtual desktop infrastructure environment. And then we'll wrap up by just telling you how you can get more information, showing you some links, and doing Q&A. But for Q&A, you'll notice there in your window, there should be a chat window where you can enter questions. Feel free to do that throughout the presentation, even while we're presenting, and we'll be answering questions all along the way. Note that this webcast will be archived and will be available on Oracle's website in the next day or two for replay, as well as will the slides for download. So Oracle has the industry's most complete virtualization portfolio, not only on the desktop side, which we're really talking about here, but also on storage and server virtualization. We have a number of products, really the broadest collection of products end-to-end available in the industry today. Today we're going to focus on Oracle's Secure Global Desktop product, which is actually slightly different. It's not what you'd think of as, despite the somewhat odd name, it's not quite what you think of for normal desktop virtualization. It's really about providing application access as well as access to server-hosted desktops, but that's what we're here to talk about today in this presentation. One of the most important things I also want you to walk away in here is feeling comfortable and completely assured that Oracle is deeply committed to the desktop virtualization space. As examples of this, since the acquisition of Sun Microsystem closed earlier this year, Oracle has done a new release on essentially every single product in the desktop family. This is from the hardware side, including the Sunray 3 family clients, of which the 3 Plus is pictured here, but also on the software side for the software, the Sunray software, server software, the virtual desktop clients and virtual desktop infrastructure software. VirtualBox, that many of you know very well, has gone through many releases with lots of enhancements. And of course what we're here to talk about today, which is Oracle Secure Global Desktop 4.6. We've done more than a release a month, in many cases multiple releases a month on the hardware and software front. This is a really key business for Oracle. So let's get into why that is and why Oracle is so interested in this business. If you're familiar with Oracle, you know that a key component of our corporate strategy is the ability to provide truly end-to-end, full-stack, top-to-bottom solutions, because Oracle can provide everything from the hardware layer for software and storage all the way up to the application layer. From a desktop virtualization stack perspective, Oracle provides similar capabilities. We can provide everything from the hardware or software client, the hardware client being the Sunray thin clients, or on the software side, we have a soft client for the Sunray environment called Oracle Virtual Desktop Client, but also complete ability to provide access to desktops either hosted as virtual machines or as applications in effect running on being hosted in your data center. So Oracle's virtualization desktop portfolio provides Oracle and Oracle's customers with a way, with a lot of flexibility and freedom to securely remotely access applications, desktops, and sessions that are running in the data center centrally, where they can be more efficiently managed and controlled. So Oracle is interested in the Oracle Desktop Virtualization not only for its ability to provide more efficient ways to provide desktops to users, but also as a way to provide an access layer for our enterprise applications. This makes access clients, easier to deploy and manage and support for enterprise application, and the access itself becomes more secure and available from a broader range of devices to enable customers to roll out their access quickly to a broader audience with more control and more security. But to talk about that, to talk about Secure Global Desktop in detail, I'm going to turn it over to my colleague, Brad Lackey, who's going to tell you about the features and architecture of the product, as well the background and how it's useful. Brad?
All right, Adam, thank you very much. So typical IT issues and IT business challenges when it comes to user productivity, we find three distinct areas where that are almost opposing in their needs and desires, right? So IT is trying to improve the information access, right? Users want their data wherever they're at, from whatever device they're using. That data needs to be consistently accessible. But while at the same time, IT organizations are trying to increase the security of that data, right? So they're trying to bring the data closer to themselves. They're trying to keep that data more local to the data center. From a physical and logical standpoint, they want to keep that data off of those laptops and such that can be stolen. In addition, they want to be able to control access to that data on a much more granular level than ever before and be able to track who's been accessing that data. At the same time, everybody has budgets that they need to hold to, and IT spend is becoming scrutinized as all of our businesses are being affected by the global economy. So we're really trying to become more efficient with IT management, right? Lower the operational costs, improve the desktop and application support efficiencies, and reach those levels of spend that will help the business. So the solution to this problem, or one of the solutions to these problems, is we like to use our Oracle Secure Global Desktop product, right? We want to improve that information access. We want to increase the mobility of our users while at the same time increasing the security of the data that travels across to those users. We want to be able to control who and where and when and from what device. All at the same time, we want to ensure that data is available. And so Oracle Secure Global Desktop, and you'll hear me use SGD as an acronym for this product. Secure Global Desktop, lots of syllables there. Really helps to bridge the gap between the centralization of data and the mobility of users and the variability of their clients. So what is SGD? So we consider it's a secure remote access to server-hosted applications and desktops, right? So this essentially web-enabled software. So whether you're coming from a PC or a Mac or a thin client, you can get to the software that's delivered out of the data center. So that's eases deployments. It's all browser-based. It's securely accessed over SSL and encrypted links. And it provides access to these centrally hosted apps that can run on Unix, Windows, mainframe and midframe applications, and all of this with a very lightweight and non-intrusive installation. And at the same time, we're doing industrial-grade network security where every component is secured with all of the compliance and regulatory compliance standards for data encryption, and we're able to do this through any DMZs and firewalls. This is a very friendly application access mechanism. Single port, single tunnel, those kinds of things, which really complete the picture when remotely accessing desktops. So what does SGD look like? So SGD is really broken down into a couple of components here. On the front end, you have your access device, PCs, Macs, Linux, thin clients, and those are connected only by display, keyboard and mouse, and USB to the Oracle SGD servers. And now these servers are responsible for authenticating the users, deciding which applications the users have access to, and then those applications are accessed by the SGD server on the back end. You see we have server-hosted apps, and these applications come from a wide range of platforms. We access these applications through the platform's native remote display technologies, and then we tunnel that through our display technology with SGD. So in SGD, that's the AIP protocol, that's Adaptive Internet Protocol, and we'll talk about that a little bit in a later slide, some more specifics. But what this does is that actually disconnects the application from the OS that it's being displayed on. So the app itself sees, oh, I'm running on Windows Terminal Server, I'm running on a Solaris instance, and the application runs along fine. But its display and its input and output come from this remote client. And the beauty of that is that the remote client now doesn't have to know how to talk to these back-end application protocols, right? They don't have to know anything about X11 or 3270s or the pain of RDP connections. And so it essentially decouples the application from their display. But how does this scale, right? So we've talked about the basic components, and we said there's an SGD server and there's various application servers. Well, each of the tiers can be scaled for very small deployments all the way up to very large deployments. The SGD servers, we use the term an array, and an array of SGD servers shares policy and configuration data amongst themselves, so that as you grow or add capacity with multiple SGD servers, the configuration and any policy for each user gets propagated to each of those devices. We also can support geographically distributed models where we have some level of control over to which SGD servers users get their sessions from. And as we do this, individual servers can be taken offline for maintenance and upgrades and those kind of things. And we essentially add users as it grows. On the application server side, you can add multiple application servers of various types, and you can add groups of application servers that provide the back-end applications to the users. And these servers we dynamically load balance against those using typical capacity-based load balancing. We can use Microsoft Network Load Balancer. We have other mechanisms that we can retrieve the number of sessions, and we assign through our policy which users get which applications from which application server. So each tier is scalable at this point, and each tier is redundant in its own right and has the ability to manage that scalability. And as we go through here, since this is a one-way conversation, feel free to use Q&A. I see some people using Q&A. And definitely use that. We have a couple of people standing by, experts standing by to answer your questions. So SGD, not only does it ease the publishing of typical enterprise applications, but also applications that are delivered through a web browser. So we have the ability to publish web browsers specifically from the back end to the client. So, if you have applications that require specific ActiveX controls or specific Java deployments, and in a lot of cases specific security configuration, it's sometimes difficult to maintain that configuration on all the various clients that users may be using, right? So it's the user goes home to a home PC for remote work. They VPN in, they use their browser. There's no way to guarantee that the security settings of that browser. And some applications, frankly, are only supported on older versions of Internet Explorer. So if you're using Windows 7 and you've got an IE6 only application, then you have a mismatch, and you can't do multiple browsers at the same time, particularly when using Internet Explorer. So with SGD, we can publish into whatever browser a user is using on their desktop an application from the data center, and that application happens to be a controlled browser where we understand the configuration, the setup, and then that browser reaches back to its enterprise application data store. So how does this really improve this manageability and security that we're talking about as one of the IT issues? If we maintain applications and do those hosted in the data center, those applications are then pushed to the user. That only means there's one spot that you need to manage the application. There's only one spot you need to patch it or update it or make changes, and only one place that you need to secure the application. That means that security between your application tier and your data tier can be restricted. So if you have firewalls between those sections, you know that the access mechanism is going to be the SGD application servers and not a whole range of IP addresses and a whole range of TCP and IP ports. So what that does is that gives you another layer of abstraction from your data, which not only eases management, but it increases security. So once we've decoupled the user from where the application is running, and we're controlling access to that application from a distribution point, we now know who's been into what apps, right? Who started app, how long were they running it, what time of day were they running it. We can encrypt all of that over SSL. So this increased security by decoupling is very much a very strong point of data center delivered desktops and applications through SGD. So on the client side, when a user comes in to use SGD, we really want SGD and have designed SGD to give a native look and feel to the application. So the applications operate as individual windows. They're individually resizable. They move and act just like applications that are local. The user doesn't need to know how to install or initiate them or do anything differently than they have been on their current client. All of the applications are initiated from a browser. They open their web browser. They log into the SGD server. The SGD server then presents them a list of applications that they've been provisioned, and those applications can be that provisioning of those can be an individual basis. They can be from which groups they're in a corporate directory structure, and after they open their applications, they now have the ability. The applications launch in a window. They can copy and paste. If permitted, there's some server-side configuration on the SGD server to tell whether users are able to copy data out of applications that are published. So this is a big security step, and that's granularly configurable by user. Users can also open and save local documents that come from their client, but are then opened by the remotely published application. And they can also print or not print to local printers. And all of this is controlled by policy of which user, which app, and can be controlled by groups. So now if you have an ultra-secure set of data, you could turn off copy and paste, you could turn off local open and save, and you could turn off print. And their users are really down to screen scraping type technologies, and there is no large amount of data dump from your application. So it's a significant improvement in access to data and security of your data. On this slide, we have an example of what the web client looks like. On the left-hand side, you see a list of applications after the user has logged in. Once they've logged into the website, there's a small bit of a Java helper that loads a small local binary, and that binary is written in the language or written in is compiled for the various clients. So this local binary client has, the reason we went with that direction is it performs much better than other Java-based clients and web-based clients. So it doesn't require any administrative rights to download this binary. It doesn't require any installation procedures or steps. This binary comes down when you go to the web browser. And what this allows us to do is map drives from our clients. It allows us to operate and move the seamless windows around. We can do audio mapping, downstream audio from these applications. So if you have an application that needs to make your beeps and boops or playback sound, those kind of things come back down. The other thing that the client does is printer mapping, and we have the ability to do this universal print driver. So in order to subdue the wide range of printers and print capabilities on the various clients, we actually can convert the print jobs to PDF, and then the PDF comes down to the client, and then it's up to the client to open the PDF and print it to whatever printer and convert it through whatever filters and do all the magic of the world's 10,000 or 100,000 different printers. It's a lightweight client, and it's very seamless to the user. It's very browser based. All of the SGD servers are administered from a central administration tool. This web-based administration tool sets policy. You can publish applications from here and decide which users and which directory groups get access to which applications. This is also where you define your application servers, take application servers online and offline. All of that's managed from one server, and all of that configuration data gets propagated out to the various servers and locations. So secure user mobility. Let's say you have an application that you have running. Just because you close the application from one client doesn't mean you can't reconnect to that running application on another client. So that way you can move from system to system to system. In this case, we're showing an apps moving from a PC to a Mac to an Oracle Thin client. And what that does is again, that's the advantage of decoupling your applications from the client. That gives users the ability to roam from system to system, gives that ultimate mobility, work from home worker, pandemic, we need to turn up a call center very quickly, very, very mobile users. So this decoupling from the client not only gives you the data security, but it gives you the mobility as well. So network performance. When you decouple the applications from the client, obviously you need the application needs to operate and function as well as it did on the client. And to do that, for SGD, we've got our Oracle Adaptive Internet Protocol. Sometimes you'll hear it called AIP, AIP. And the AIP protocol is a TCP-based protocol that is very performant over LAN and WAN connections. High latency, very low bandwidth connections. AIP does a very good job of adjusting on the fly to these conditions. So we determine compression ratios. We determine the number and amounts of packets to send in order to give the best user experience for a given network condition. And that condition is monitored on the fly, and those calculations and those tunables are changed automatically by the protocol. When compared to X11 applications, which in the Unix world is a typical remoting protocol, X11 is very bad. We get well over a 10-to-1 compression of X11s, because what we've done is we're keeping X11 to the data center. We do the same with RDP and other protocols that don't do a very good job of handling the latency and particularly the network changes over a period of time. So we keep all of those to the data center, and we use all AIP out the front end. So what happens if you want to put SGD on the edge of your data center or the edge of your network? That way, users from any device, so without the need of a VPN, we've developed the SGD Secure Gateway component. Essentially, it takes a couple of pieces of SGD and moves those into its own server component that can be placed in the DMZ. And this gateway obscures IP addresses, host names, those kind of things from the inside, but still allows SGD and its SSL and port forwarding to be sent through the DMZ and out to your clients. And what this is this essentially can replace or substitute SSL or other VPN gateways. Since all of SGD's traffic is tunneled over SSL and tunneled over actually port 443 SSL, it fits very well through typical firewalls and typical DMZ type of requirements. And what that does is that from the one SGD product, you now get a remote access solution for your applications and desktops, as well as a secure access for those devices that are on the other side of a typical tunnel. We use an Apache reverse proxy to do some of this. We do all of our authentication in the DMZ ahead of time before granting access to the SGD servers back in the data center. We have the option to leave some of the data unencrypted between the gateway and the SGD array for sensor inspection. Again, we can scale out these gateways for redundancy and scalability if we get large numbers of users. And all of that functionality is contained in the SGD licenses that you purchase. So there's not extra products for that from us. So we don't have a web access gateway, and we don't have a separate security gateway and all those kind of things. Those are all components of SGD. So a bit about the security and data protection. So we use all of the highest industry standard encryption and cipher levels. All of those are available through every step of the way. So not only user traffic, but internal array-to-array traffic is encrypted in the same cipher and encryption levels. We use PKI certificates to verify the identities of all of our servers. And so what that gives is every component has been tested and has been secured at the appropriate levels to guarantee this end-to-end security of your data. Not only can we secure the transmission of the data, we can secure the extraction of the data. As I mentioned before, we have policy-controlled restrictions to these end users, right? So we can keep people from copying and pasting credit card numbers out. We can keep people from connecting one of their client drives up to the SGD server and uploading a virus. We can keep them from printing out reams and reams and reams of satellite imagery that's secure. So all of that is contained in this product and can be controlled via policy. So failover and load balancing. Within an SGD array, this array of configuration and policy and load balanced array, we have there's one that's the primary, and this primary is really where writes change, and then those writes get propagated out to the secondaries. If the primary goes down, we have automatic failover of this primary. So admins will pre-select a secondary server, and it will automatically self-promote when the primary goes down. And what this gives you is a failover capability of the primary without administrator interaction or the response time from oops, we had a green light on our display go red, let's figure out why and triage it and then decide you need to fail over because a board died in one of your servers. So this is automatic for our primary. In addition, the takeover is instrumented, and so we can revert back with a few clicks back to the primary after the primary is back on. Load balancing amongst the failover group. So when a user connects initially to SGD, the SGD server decides which server in the failover group to start their session. And then within that session, they decide which of the servers to start bringing, which of the application servers that their application be run on, all based upon load, and we gather some metrics and those kinds of things. And all of this wouldn't be complete without very detailed ability to control which users get access to which applications. So we support LDAP, LDAP-S. We can do Microsoft Active Directory, Novelty Directory. We can authenticate against using Secure ID. We can authenticate at the web browser, web tier layer, in addition to the Unix layer. And what this does is we can not only authenticate against those various forms, we can use data within those directories to determine group membership, to determine which applications users have access to. One of the things that we added in Secure Global Desktop over the years was the notion of enterprise interoperability. Each component of the SGD product has a set of APIs and web services that allow them to be controlled remotely. So we can change the user interface. We can integrate with portals and other environments on the front end. These components use industry standard SOAP and XML protocols and data sets. So what happens is that now you can integrate this in with your other enterprise components and enterprise software, so that SGD feels even more seamless to the user. Can be part of your identity management suite. Can be part of your access provisioning suite. All of those enterprise-based protocols are supported here. So I'm going to step back a little bit and talk about the other component that SGD is good at delivering. Is not only do we deliver applications very well through SGD and has been historically done so, you can apply the same logic with delivering virtual desktops through SGD. So not only do you get your instant VPN tunnel or SSL tunnel, you get access to virtual desktops. But the combination of SGD and a VDI environment gives you some architectural advantages and efficiencies that we'll show in the next couple of slides. So for those of you who may not know the topic, and this has kind of been a hot topic over the last year or so, is the virtual desktop infrastructure essentially takes your desktop and runs it as a VM in the data center. And Oracle's virtual desktop infrastructure software manages those VMs on the back end. So not only do those VMs run in the data center, they get backed up, they run on data center hardware, they are protected through data center security and firewalls, and access to those is decoupled from the client, much like we do with SGD. So the Oracle Virtual Desktop Infrastructure, we support a bunch of OSs on the back end, Windows XP, Vista, 7, 2000, Open Solaris, Ubuntu, and SUSE. And what that does is that gives you access to multiple VMs on the back end to your client on the front end. And the reason we're touching about VDI here is what happens when you couple in a Secure Global Desktop as a part of your virtual desktop strategy. Typical user desktops are sort of a combination of categories of applications. Those are applications that are unique to them or configured for them, and that'll be things like the OS and the apps that are installed on that OS, and things that are specific to a group. So that will be applications that are published to all users, right? So the configuration of those apps needs to be consistent across all users. The versioning of those apps needs to be consistent of all users. And that sort of dichotomy on the desktop really leads to SGD being a good insertion here, where now what we do is we deliver those apps that need to be managed centrally. We deliver those into the desktop image through SGD, and then the rest of those user config, OS-specific applications and files live within that desktop, and that entire thing can be delivered as a data center-based virtual machine out to users via thin clients and PCs and Macs and other hosts. So the splitting of SGD to pull those apps out of your VDI environment gives you the multiple tiers. So not only you're combining desktop publishing, you're combining that with application publishing, and you're getting all of those products that are integrated and tested together. So Secure Global Desktop and VDI, like we said, it's efficient and flexible. We can decide which apps to which users on which VMs from which device. We can control all of those things. That gives you the ability to rapidly patch, minimize all the various management tools that you have. I know a lot of IT organizations have spent big dollars on tools to manage the applications on a PC. Not only is it to install them and patch them, but to make sure that the configuration of those apps didn't change since the user got a hold of it. And this, a lot of that can be mitigated by publishing the application centrally into a desktop that's running centrally and managed centrally out to a device that could be an unmanaged device, whether that's a user's personal system at home or their personal laptop, or a managed device, or even a thin client device that requires no management. So to wrap up a bit with Secure Global Desktop. So Secure Global Desktop consolidates applications to run on data center servers. That's multiple application types. So that's Windows and Unix and mainframe applications. All of the data to those applications resides in the data center environment, and the protection of that data gets abstracted to the users. So we regardless of the device type, the users get access to the application in the way that the administrators have configured it, in the versions that are there, and we secure access to the data within that application. So we solve the data access problems while at the same time increasing this security and of the data, and trying to reduce the manageability work and effort when it comes to PCs. So, or PC-based delivered applications. So thank you for listening. That's all I have. I'm going to turn it back to Adam. Adam?
Thanks, Brad. So we'll be getting ready to go here into a chat. We've seen a number of questions come along, and please keep sending those questions in chat. We'll be answering some of those verbally here momentarily, and so feel free to enter any questions that you've got in the chat, and we'll answer you either in chat or coming up here in the audio Q&A section. Before I move on to tell you about how to get more information, I wanted to remind you this is part of an ongoing series. We have the next set of virtualization webinars are coming up starting on December 7th, where we have a session on enabling private clouds with Oracle VM and talking about our Oracle VM server-side virtualization. And then we'll have on December 9th a session talking about our Sunray 3 client. We've just introduced and refreshed the entire hardware product line for Sunray client with the Sunray 3 series, and these are really reaching kind of new levels of eco-friendliness and efficiency with extremely low power operation and integration with all the products we've been talking about. And there'll be a number of these every month, so feel free to check back often and look for those. All the webcasts we have, by the way, that we've done in the past are also archived on our website at oracle.com/virtualization. Let me go to that. Oops, wrong slide. Let me go to the right slide. And, well, we seem to be having some sort of technical difficulty here. All right, there we go. We have the slide here where you can always go to oracle.com/virtualization. This will, you can find here the replays of this and other webcasts by going to that web page, clicking on the events section, which is over there on the right-hand side, and you'll see some of the webinars there. Also, this leads you off to our desktop virtualization portfolio as well page, as well as our server portfolio. On each one of those pages, also click on the event section, and you'll see previous webinars or notices for upcoming webinars. You can also take a look at our OTN, the Oracle Technology Network forum, where there's active discussion on these and other products. And also under Oracle blogs, there is an Oracle virtualization blog covering all of our virtualization products. Again, feel free to at this time, put in any questions that you have in chat, and we would be glad to Brad and I, to answer those to our best of ability here. So when we were, there was a question came in, a couple that were interesting earlier that are worth repeating, which is that, is this basically an equivalent to XenApp from Citrix? And the answer is yes. Essentially anything situation where XenApp, or otherwise known in the older days as presentation server or way back as MetaFrame, this is applicable in a lot of really similar scenarios. We tend to have a lot more focus on non-Windows platforms, so we support, as was mentioned, Unix platforms, mainframes, AS400 in addition to Windows, but we're very applicable there, as well as, certainly in the cases where you want to integrate with your Sunray Thin Client environment or VDI, then this would be the product for you.
Adam, I have a comment on that real quick.
Yeah, sure.
In general, the idea is very similar. The approach and application with SGD is quite different. With XenApp presentation server, this was an install on top of Windows Terminal Server, and so it was an additional level of software installed in that tier. With SGD, we actually take that tier, and it's not a software base; it's another tier in the architecture, rather than installing on top of terminal services. And what that allows us to do is get apps from terminal servers as well as apps from, as you said, Unix apps and those kind of apps. In addition, we do the SSL encryption and the SSL tunneling all from within the SGD web tier. It's a single product from us to do that. So it's the idea in general is the same about centrally hosting applications, but the approach is definitely quite different.
All right, yeah, thanks for expanding on that, Brad. So there was a question here that popped up about, is SGD 4.6 supported on Solaris 11 Express? The answer is no, not today. That'll definitely be coming. For those of you that don't know, Solaris 11 Express just recently released, I think last week, it was, or certainly in the last week. Solaris 11 Express is a general release, or I should say a fully supported for production use release of Oracle's latest version of the Solaris operating system. Why the word Express on the end? Well, there are still some more features that are going to be added in over the next year prior to the full release of Solaris 11. So this is fully supported. It is an official release. You can use it in production today. There will be some functionality added to it in the next year, and then it'll just become Solaris 11. So this is enabling customers to get access to Solaris 11 to start their qualification test and get access to a number of the great features there, including a new packaging system that allows the system to be more easily maintained and patched and configured, along with a whole host of other things, including things such as using removal of the root, the general root that has been in use forever. Now root becomes a role, it becomes an attribute as part of role-based access control, so that you can more closely control who's accessing through root. Let's see, do you have anything, Brad, on your list here that, amongst all these, that's interesting to comment on?
Let's see. I think a lot of the specific ones have been answered. Anything I want to call out?
I've got one here. Let's see. So sorry, we're just chatting or looking across these as they come in. So there's a question here: is does SGD software come included with VDI software, and does it require a separate license? It's available as what you get with VDI. There is a restricted license that is included. The restrictions relate to One, that you can only use it in that context for accessing Windows Server, and two, that a given user can only access a single desktop image as opposed to multiples with that limited license. If you wanted to use SGD in the VDI context to access other operating systems or more virtual desktops per user, then you would have to buy the standalone VDI licenses. The standalone VDI licenses are available either as a Windows-only license or as a so-called all-platform license, meaning that includes all of the operating systems that we support. It's worth mentioning here, by the way, that in that context, that Oracle's VDI software supports more than just Windows. We also support Linux and Solaris virtual machines as desktops. This makes us pretty unique in the industry. We have a unique ability with our VirtualBox software to actually supply RDP from basically any operating system, Linux, Solaris, Windows, and even older versions of Windows that don't have RDP in them. This gives us greater flexibility and gives customers the ability to use a VDI type infrastructure beyond Windows. This is really helpful for companies that, say, have Windows as their primary desktop but may have a collection of developers that work primarily off Linux, but they want to get, or Solaris, but they want to get the VDI benefits of central management. Okay.
So one question we're getting about role-based SGD admin console. Obviously it's something we are considering for a future release, and since the product was acquired by Oracle, we now have access to a lot of really nice administration interfaces from Oracle that have many features, enterprise-based features that the development team is looking into the possibility of their integration. So it's actually good for our product because we get access to a lot of those components, and it's good for a lot of legacy Sun products as well.
Okay, let's see. We have a number of questions here. A lot of these are all variants of things that we've got, so we've kind of covered some of these.